And now we're going to look into vectors in 3 dimensions, or vectors in space, as it were. So here are the rules for all of the different forms of addition, subtraction, scalar multiplication, and so forth for vectors in space, or vectors in 3 dimensions. You'll notice that they're all just extensions of exactly what we did in the previous section. So scalar multiplication works the same way. We multiply some scalar k by our vector. We're going to multiply it component-wise, each bit. When we add vectors together, the x's get added together, the y's get added together, and then the z's get added together. So all components. The same with the vector subtraction. Also, if you look down here, the vector magnitude, instead of it being just this part, where we have the x and the y squared within the radical, now we also add the z component under the radical. And the unit vector is the exact same formula as it was, only for each of the 3. And the last thing, as far as new notation or whatnot, the vectors for 3 dimensions, if we break them up into the forms we had I and j before, now we've added a k. And so the vector I will equal 1, 0, 0. The vector j will equal 0, 1, 0 for the y component. And then the vector k will equal 0, 0, 1, and only keep the z component. All right, so let's try to take a look at problem number 81 from your book. Let me scroll down a little bit. It says, find the terminal point q of the vector that goes between p and q, which has that vector, with initial point at -2, 2, and -2, 3, and 5, which is p. So our initial point is p, our terminal point is q. We need to figure it out. Well, we're given what this vector is, and we know that we've got pq as a vector is going to equal x minus a -2 will be our first point. And then it'll be y minus 3 will be our second part of that, and z minus 5. That's what our PQ is going to be, but we already know the values for that. So for this first one, we know that x, in fact, x plus 2 is what that turns out to be, equals 7, which means x equals 5. Y minus 3 has to equal -1, which means y equals 2. And finally, z minus 5 equals 3, which means z equals 8. So this, our q, that doesn't equal anything, but q will equal 5, 2, and 8.